Good morning to one and all present here. Today I am going to take the topic on Lagrangian multipliers. The Lagrangian multiplier definition, we are going to see the definition now. Lagrangian multipliers are used in multivariable calculus to find the maximum and minimum of a function subject to the constraints like find the highest elevation along the given path or minimize the cost of materials for the box enclosing a given volume. This method is a useful way to determine the minimum or maximum of a surface subject to a constraint. It is an alternative to the method of substituting and works particularly well for nonlinear constraint. Next, we are going to see the formula. For example, all the surfaces will be denoted as f of x, y, f of x, y, and all the constraint as g of x, y. Now we have to write the auxiliary function. Capital F of x, y is equal to small f of x, y plus lambda into g of x, y. This small f of x, y is nothing but the surface of the given and then g of x, y is subject to the constraint. So next we are going to see the problem. A rectangular box open at the top is to have a volume of 32 cc. Find the dimension of the box that requires the least material for its construction. So consider the rectangular box. So in the rectangular box we have the 6 sides is having. So out of the 6 sides the top is open and also given the volume is equal to 32 cc. So now we are going to find what is the dimension of that box. Let us first consider the x, y, z be the length, breadth and height of a box. Given volume of the box is 32 cc. Then we have to write the subject to the condition x, y, z is equal to 32. Here x and y, z all are greater than 0. The surface area of the rectangular box is given s is equal to xy plus 2xz plus 2yz. Since here the one of the top is open, so we can write this as at xy. Next we are going to write the auxiliary function. Capital F of x, y, z is equal to the surface area plus lambda into volume. This lambda is nothing but the Lagrangian multiplier. So now we are going to differentiate this auxiliary function with respect to x, which is equal to, so first term differentiating with respect to x, the first term we get the value only y, that is the differentiation of x is 1. Next one plus, here also differentiation of x is 1, so we get only the 2z. Then here the no x term is having, therefore this term is equal to 0. Then the last term we have a multiple of x, y, z is having, so here you have to keep the y, z as constant, then differentiation of x is 1. Then the differentiation of this constant value is equal to 0. So therefore we got lambda y, z. Then next we have to differentiate with respect to y. For differentiating with respect to y, the first term we have a y term is having, the differentiation of y is 1, so we get x. The next one, here no y term is having, therefore this term is equal to 0. Then here y term is having, the differentiation of y is 1, so we get the 2z. Then here also you have to keep the x and z as a constant, differentiation of y is 1, so lambda xz. So next we are going to differentiate this auxiliary function with respect to z. So first term no z term is having, therefore 0. Second term we have a z term, the differentiation of z is 1, so we will get only the 2x. Then here the differentiation of y is 1, so we get the 2y. Next plus here differentiate with respect to z, we get lambda into xz. So next we are going to find the stationary point. To solve the stationary point, we have to substitute fx equal to 0, fy equal to 0 and fz is equal to 0. If we substitute fx equal to 0, so we get y plus 2z equal to minus lambda z. Next is fy is equal to 0, we get x plus 2z is equal to minus lambda xz. Then put fz is equal to 0, we get 2x plus 2y is equal to minus lambda yx. After solving this equation 1, 2 and 3, we get x is equal, that is equating the first equation and second equation, we get the value x is equal to y. Then equating the second and third equation, we get the value y is equal to 2z. So from these two equations, we get x is equal to y is equal to 2z. So substituting all the values in the volume, given volume, so we get the z value. Z cube is equal to 8, then z is equal to 8, 2. So from this, substituting this z is equal to 2 in, x is equal to y is equal to 2z. So we get x is equal to 4, y is equal to 4. So now we found out that dimension of the rectangular box. The dimension of the rectangular box is 4 cm length, 4 cm breadth and 2 cm height. Next, we are going to see the next problem. Problem number 2. Obtain the volume of the largest rectangular parallel pipe that can be inscribed in an ellipsoid. So the ellipsoid equation is given x square by a square plus y square by b square plus z square by c square is equal to 1. So now we know the length, breadth and height of the rectangular parallelepiped is 2x, 2y and 2z. That is, the volume can be written as 2x, 2y, 2z, which is equal to 8xyz. Now we are going to write the auxiliary function. So auxiliary function, so first we have to write the volume of that rectangular parallelepiped plus lambda into that ellipsoid equation. So this lambda is nothing but the Lagrangian multiplier. So now we have to differentiate this auxiliary function with respect to x. So while differentiating with respect to x, the first term, the multiply of xyz is having, then the differentiation of x is 1. So we'll get 8yz plus, next this term, differentiate only the x square. What is the differentiation of x square? We'll get the 2x. Then this term is 0, this term is also 0. So we get 2 into lambda x by a square. Next, differentiate this function with respect to y. So we get the first term we doesn't have a first term we have a multiply of xyz having, the differentiation of y is 1. So the remaining we will get 8xz plus lambda into, so here the first term no, y term having 0. So second term we have a y term, that is y square. Differentiation of y square is 2y. Then the last term is also not having the y term. So therefore this is also 0. So we get 8xz plus 2 lambda y by b square. Then differentiate this function with respect to z. So here we get the differentiation of z is 1. So we will get 8xy. Then plus lambda into, here you will get the 2z. So lambda 2z by c square. Next we are going to find the stationary points. So solve this fx equal to 0, fy equal to 0 and fz is equal to 0. So if we put fx equal to 0, we get the equation of the form minus 4xyz by lambda equal to x square by a square. Next put fy is equal to 0. We get the value as minus 4xyz by lambda equal to y square by b square. Then put fy is equal to 0. We get the 4xyz by lambda is equal to z square by c square. Then equating these all three equations, we get x square by a square equal to y square by b square equal to c square, z square by c square. We know the ellipsoid equation x square by a square plus y square by b square plus z square by c square equal to 1. So this substitute this value, any one of the value instead of x, substitute y square by b square as z square by c square. So here we are keeping the x square by a square as constant. Then instead of y and z is substituting x square by a square. So after substituting this, we get the x is equal to plus or minus a by root 3. So substituting this in equation this one, we get the y is equal to plus or minus b by root 3 and z is equal to plus or minus c by root 3. So now we find out the maximum volume of the rectangular parallelepiped, which is equal to, there is a volume we know that 8xyz. So x value is a by root 3, y value is b by root 3, c value is z value is c by root 3. So we take only the positive value because we already mentioned that the volume is always, there is x comma y comma z is greater than 0. So only take the positive value. So no need to take the negative values. Okay. So next we are going to the next problem. Problem number 3. A thin closed rectangular box is to have a one edge equal to twice the other and the constant volume 72 meter cube. Find the least surface area of the box. So here, what is it? There is a rectangular box. We know that the 6 sides is having length, breadth and height. So here, what is the given? One edge is equal to the twice the other. So therefore, you have to consider x as a length, y as a breadth and the twice the other edge. No, so consider as 2y. Be the height of the rectangular box. Now we have to write the surface area of that rectangular box. The surface area of the rectangular box is length into breadth, 2 into length and breadth, so 2xy. Next 2 breadth into height, so 2 into 2, 4y square. Then next plus 2 into height length plus 2 into 2 to 4 into xy. So we had to add the 2xy plus 4xy, get the 6xy. Then this 4y square right as it is. Then the volume, what is the given? 72 meter cube is given. So volume xyz is equal to 72. So now we have to write the auxiliary function. Capital F of x comma y comma z is equal to small f of x comma y comma z. That is the small f of x comma y comma z is nothing but the surface area of that rectangular box. Then g of x comma y comma z is nothing but the volume of the rectangular box. Then after writing the auxiliary function, differentiate this function with respect to x. So only we have a two variable x and y. So no need to differentiate with respect to z. So only differentiate with respect to x and y. So we get the fx and the fy. So first to differentiate with respect to x, we get 6y plus lambda y square. That is only with respect to x we got. Then next, differentiate with respect to y. Differentiate with respect to y, we get 6x plus 8y plus 2 lambda xy. So after finding the differentiation, we have to find the stationary point. So for that one, we have to substitute fx equal to 0, then fy is equal to 0. So after substituting this one, we get the value y is equal to 3 by 4x. Then substituting this y value in equation, any one of the equation, we get the x is equal to 4. We got the x is equal to and y equal to. Therefore, next we are finding the minimum surface area of the box. So, minimum surface area of the box, in a surface area, you have to substitute the x value and y value. So, we get the minimum surface area of the rectangular box. Hope you all understand this Lagrangian multiplier. So, these are the problems you have to try. Try this one. Here, what is given? Find the shortest and longest distance from the point 1, 2, minus 1 to the sphere using the Lagrangian method of constraint maximum and minimum. That is, we are going to find, first you have to write the shortest and longest distance from this point to the sphere. Okay, we know that distance between the 2 points formula. Using that formula, you can find the subject to the condition and the surface area. Next problem, the temperature u of x, y, z at any point in the space is u is equal to given. Find the highest temperature surface on the sphere x square plus y square. Here also unit sphere is given. Here the temperature is also given. That is, we are going to find the highest temperature on the surface. Okay. So here write the auxiliary function as 400 xy z square plus lambda into x square plus y square plus z square minus 1. So that is an auxiliary function. After framing the auxiliary function, differentiate with respect to x, y and z. Then equate to 0, that is fx equal to 0, fy equal to 0, fz is equal to 0. You get the stationary points. That stationary point is substitute in that minimum temperature. Here the temperature, if you substitute, you get the highest temperature of the surface. That's all. Thank you.